Hello class, these are our notes for Algebra 1, Section 4.7, using graphs to find average rate of change. So first we're going to talk about average rate of change. Average rate of change is the average amount of function changes per unit interval. So that is like our textbook definition. Average amount a function changes per unit interval. All right, the other thing this really is it's just slope. So calculated by finding slope. Below is a graph of one day's temperature as a function of time. Describe the change in temperature shown on the graph over time. So looking at my scale down here, it looks like I've only got the even hours labeled for time. That's like my x-axis, my input. So even though there's a 10 o'clock right here, my graph's really starting at 9 a.m. So at 9 a.m., our temperature is 35 degrees. And it looks like our temperature is going up. It kind of levels off again, and it's going up again. So let's go ahead and talk about what's going on from 9 to 2. And there's lots of different things that you can say that are true, right? Like we could say exactly what I said. It's increasing from 9 to 10, stays the same from 10 to 11, increases again. You could say all of that. I'm going to talk about just from 9 a.m. to 2 p.m. The temperature increased until the max. But not at a constant rate. It was not a constant rate of increase. And this isn't even maybe the best thing to say, right? I'm just talking and giving a bunch of true words. So you might have a better, nicer way of wording this. So what I mean by not a constant rate is it looks like it's going up pretty steep here, and maybe it's not as steep here, and here it looks like it's leveling out. So it's not just like one line connecting the 9 a.m. with 35 degrees to the 2 p.m. 45 degrees, right? It's not changing the same amount per hour. It even looks like the slope is different here versus here. So it's kind of different all the way through there. All right, what happens next? For example, this is something else I wrote earlier. The temperature stays constant, or stayed constant from 10 to 11. From 10 a.m. to 11 a.m. It's kind of bugging me we didn't say anything about that. From 2 p.m. to 8 p.m. the temperature decreased. Once again, it was not a constant rate of change. This is way more detailed than what you'd need to have. You could have just said increasing from 9 to 2, decreasing from 2 to 8, right? You could have said that. You could have given some specific numbers about what the starting temperature was and what the maximum was. There's a lot of different right answers for a question like this. Next, we want to calculate the average rate of change from 9 a.m. to 2 p.m. So remember, our average rate of change is going to be our change in output divided by our change in input. So I'm really kind of doing a slope formula here. So at 9 a.m., my temperature was 35. And then at 2 p.m., my temperature is 45 degrees. So my slope is going to be 45 minus 35. I'm subtracting my outputs. I'm subtracting my y values over the 2 p.m. minus 9 a.m. And 2 p.m. minus 9 a.m. is really weird because I can't just really do 2 minus 9, can I? That would be -7. That's not right. I've got to figure out exactly how many hours are passing from 2 p.m. to 9 a.m. And if you're not sure, we could count on our graph, right? Temperature went from 35 to 45. That's 10 degrees. And then if you look at our time, it's 1, 2, 3, 4, 5 blocks of time, 5 hours. So 10 degrees over 5 hours, which means 2 degrees Fahrenheit per hour. So the temperature increased at a rate, or at an average rate, of 2 degrees Fahrenheit per hour. Now find the average rate and temperature from 2 p.m. to 8 p.m. Okay, so again, at 2 p.m., what was my temperature? My temperature was 45 degrees Fahrenheit. At 8 p.m., it looks my temperature was 30 degrees Fahrenheit. So what's going on in here? So I got to do my slope again. So my 30 minus 45 over, and then this was over 8 p.m. to 2 p.m. So that's going to be -15 over 6. We'd probably want to divide that out and have a decimal answer, and that would be -2.5. So -2.5 degrees Fahrenheit per hour. So that means the temperature is decreasing at an average rate of 2.5 degrees Fahrenheit per hour. So it was more drastic, right? When was the change more drastic? When it was cooling off. So from 2 p.m. to 8 p.m. when the temp was decreasing. It might have helped if I'd written these really like ordered pairs. I think it's tricky with the hours. We have a 9, 35. We have a 2, 45. But I can't really subtract my hours because AM and PM are different units, right? So be really, really careful when you're doing that. Same thing for this one. I could write 2, 45. These are both PM, so it works on this one. 8, 30. So I'm just doing a slope formula. X1, Y1, X2, Y2, X1, Y1, X2, Y2. We'll go ahead and we'll review slope formula on the next page. All right, so if 2 points on the graph of a function are A, comma, f of A, so they're wording it a little bit differently for slope formula this time around, and B, comma, f of B, then our average rate of change, which is slope, change, that's supposed to be the word change, is going to be equal to f of B minus f of A over B minus A. So this is the same thing as m equals y2 minus y1 over x2 minus x1. So remember, a different way to write these is going to be x1, y1 and x2, y2. So if we have a positive slope, it means our graph is increasing, it's going up. If we have a negative slope, our graph is going down. Find the slope of the line through the following points. So I'm just going to use slope formula for these. I could use this new formula in function form, but it's really the same formula, right? One of them is written with function notation and one is not. So it's easier for us to use the same old formula. So let's see. So y2 minus y1, so 3 minus 11 over 3 minus -4. 3 minus 11 is -8. 3 minus a -4 is going to be plus. So 3 plus 4, which is just 7. So my slope for the first one is -8/7. Second one, x1, y1, x2, y2. So my slope is 6 minus 6 over -1 minus 5. That means we've got 0 over -6. 0 on top, 0 divided by anything equals 0. So my slope is equal to 0 here. If we had 0 on the bottom, if we had -6 over 0, then that would be undefined. So if the 0 is under, right, that is when it's undefined. We can't divide by 0. 0 is under is kind of a way to remember that. So that means my slope is undefined. So be really careful about your slope. So big ideas today are still doing the slope formula, being able to kind of look at a graph and describe what's going on with words. I think we're actually really good at that. And remember, they're going to say average rate of change. And when they say that, it really just means do a slope formula and be really careful when you're working with hours. As always, class, if you need help, please ask.